Welcome to 13.3, area of more complex shapes. So we're going to combine rectangles and squares and triangles and make more complicated shapes. Find the area of the shape if each square has an area of 1 square centimeter. So that's 1, that's 1, that's 1, that's 1, that's 1. And that's a triangle. It must be half as big, so it's a half, so it's 4 or 5. It's 5.5 square centimeters. All right, well, what about this one? What are you going to do here? You can find the area of more complex shapes by adding areas of simpler shapes. So we're going to find the area of this thing I've just outlined in red. Right? Now, if I take this line away, the area would be exactly the same. It wouldn't change the area at all. And we're going to add that line later. But you can see here that this side is 8 and that side 17. So this is 17 times 8. For this, let's use different color. So for the red here, it's 17 times 8. And then for the blue here, it's 15 times 5. And then you add the areas up. Right? So 15 times 5 is 75. And 17 times 8, 7 times 8, 56 is 136. And you add them up. And 136 plus 75. I'm getting 211 square units. And you can always do this. You can break shapes down into shapes you know how to find the area of. All right, so that's a triangle and a rectangle. Hopefully you see a rectangle down here where the area is 5 times 10. Right? Because there's 5 and a 10. Now the triangle on top, right, it's 1/2. The base is 10 times 5. Right? So the rectangle is 50 square units. The triangle is 1/2 times 10 times 5, or 25 square units. 50 plus 25 is 75 square units. Now, what happens here? Right? We don't have a formula like base times height for this shape, but we could add a line somewhere, right? And you could put it anywhere. You could put it there, right? You could make it more complicated too. You could also, you could put all sorts of lines in here, all right? You could put it there. You could put 2 lines if you wanted to find the area of 3 squares. What I'm going to do is I'm going to put it where I first put it. I'm going to put it right here. Okay, and so then I'm going to find the area of this one that I've outlined in red. And then I'm going to find the area of this one I've outlined in blue and add them up. Well, the blue one side is clearly 16 and one's 8, so one of them, and that's the rectangle, is 16 times 8. The square over here, it says it's 8 times 8. That's 64. So the rectangle is 64. The square is 64. The rectangle is 16 times 8, which is, let's do that over here. It's actually twice as big than that, so you should have an idea of what the answer is, 128. Then we add the 2 together, and 12 and 9, it's 192 square units. All right, so where do you want to add the line here? Well, I'm going to make it look like the one we already did, like that. Okay, now if you want to break it down into like all smaller shapes, yeah, you can, but I think that's the fastest. Because I now see a rectangle, which I have in blue, and one side is 8 and one side is 5. So that's 40 square inches. Top of it, I see a triangle now, right? And that is going to be 1/2 base. Now, if this side of this rectangle is 8, does that mean that side is 8? Yeah, that's a rule of rectangles. It's not a rectangle. Both the opposite sides aren't the same. So it's 1/2 times 8. And what's the height straight up? Now, I put the height out here. Is that different than putting the height there? No, as long as it's the distance straight up from the bottom, which it is, it's fine, right? And so 1/2 of 8 is 4. 4 times 4 is 16. So the triangle is 16 square inches, right? Because it was shorter. And so 40 plus 16 is 56 square inches total. All right? So once again, right, this square is 4 square miles. So this is 4, 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 this is 4. What's this triangle? It's 2. It's half as big. So we have, 8 4s, 32. So, right, those add up 32 square miles. And we have 2 extra square miles. And so it's a total, and then we're going to say approximately, because we're estimating the square of the lake. The size of the lake is 34 square miles. All right, now we're going to take this to the next level. Hopefully what you see when you look at this is you see a rectangle where I have subtracted this corner. This corner has been subtracted. What do you think you do here? So I see a rectangle that's 10 by 20. So the 10 by 20 is, right, 200. We can do that in our head, 200 square feet. And what was this rectangle in the corner? Well, it was 3 by 3. We took away 9 square feet. Now, could you have done it like the others where you added a line? Yeah, but you could do it that way, right? And it would work. But I think it's faster to take away that corner in this case. So 200 minus 9, a little borrowing to do. And 9 less than 200 makes 191 square feet total. Right, we had a 200 square foot rectangle and we took away 9 square feet. That corner is missing. All right, so now we had a large rectangle and we took away a triangular corner. All right, so the blue one, if there was no triangle taken away, it would be 25 times 12. What's 25 times 12? That's 50. Step over. I'm getting 300. So this is the blue one would have been 300, and these mean inches, 300 square inches. But we took away the triangle, so that's the rectangle in blue. Now we take away that. I'm going to do this one in red. Now the triangle is not 2 times 6, and right, it's 1/2 2 times 6. So it's not. We're not taking away 12 square inches. We're taking away 6 square inches. 6 square inches, right, lower than 300 is 294 square inches. For the blue, there is 294 square inches of blue there. It's a rectangle with a corner taken away. All right, so now this is a classic problem. You see anything like this, a pool. This is a picture frame, right? There's a picture inside here, and we want to know what the area of just the frame is. But you also see this with like a swimming pool, and this is like the deck of the swimming pool. The way to do this is not to try to break it up into little shapes. It's to do the subtraction. Because look, I see a large rectangle on the very outside. I'm going to call that the large rectangle. And inside there, we see a small rectangle. And for sure, sometime in your life, you're going to see this problem. And it stumps a lot of people. But once you know to take the center away, it's so much easier. So the outer, right, is 20 by 10. These are rectangles, 200 square inches. The inner is 16 by 6. And 16 times 6 times 6 is 36, is 96 square inches. So you have to just do a little subtraction, 200 minus 96. Again, we're having a lot of borrowing in these problems. And 4, I'm getting 104 square inches. Now, if you want to try and break these up into little squares and rectangles, and you can do it that way sometimes, but way, way harder. And that's what stumps people, that there is a much easier way. All right, so let's practice. All right, so I see a rectangle, which that rectangle is 4 by 10, right? Base times height. And I see a triangle at the end of it. And the triangle, 1/2, the base is 3, and the height straight up is 4. 3's cancel. That's 4 square centimeters. The rectangle is 40 square centimeters. I can add those in my head and get 44 square centimeters for the total area. So this is another subtraction problem. I see a rectangle with a triangle cutout. And so what you do is you find the area of the rectangle and you take the triangle cutout in the center away. The triangle is 1/2 times 9 times 6, those little marks are inches, and half of 6 is 3, so it's 27 square inches. The rectangle is 11 by 20, and 20 times 11 is, stepping over, 220 square inches. And 220 square inches minus 27 square inches. And we're going to borrow again. And I'm getting 193 square inches of blue. That's how much blue is there, right? It would be 220 square inches if the triangle cutout wasn't there. So again, you're going to put a line somewhere. I'm going to put it right there. So this blue one, I'll call it the blue rectangle, is 7 by 6. Then there is a red rectangle up here, which looks like 12 by 7. Add the two areas. 12 times 7 is 84 square inches, and 7 times 6 is 42 square inches, and you add the two together, and I'm getting 126 square inches. And you could have tried different places. You'll get the same answer if you put the line somewhere else. Good luck on the homework.